This is SpaceTime, Series 28, Episode 137, for broadcast on the 21st of November 2025. Coming up on SpaceTime, NASA's Escapade mission blasts off bound for Mars, the Pleiades star cluster proved to be far bigger than originally thought, and ending debate over interstellar comet 3I Atlas. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's first dual satellite mission to another planet has successfully launched aboard Blue Origin's New Glenn heavy lift rocket bound for Mars. The Escape and Plasma Acceleration Dynamics Explorers, or Escapade spacecraft, blasted off from Pad 36 of the Cape Canaveral Space Force Base in Florida in what was only the second flight for the 98-metre-tall New Glenn rocket, which is named in honour of John Glenn, first American to orbit the Earth. The flight had been delayed several times due to bad weather and geomagnetic storms. 3 minutes after liftoff, the rocket's first stage separated as planned and began its return journey to Earth, successfully landing on Blue Origin's recovery ship Jacqueline, which had been pre-positioned 604 kilometres downrange in the North Atlantic Ocean. The successful landing means Blue Origin is now only the second company in history after SpaceX to recover a rocket during an operational orbital flight. Meanwhile, New Glenn's second stage continued lifting the twin Escapade spacecraft into orbit. 33 minutes after launch, 2 Escapade probes were released into space to commence their long journey to Mars. The twin spacecraft, named Blue and Gold, will arrive at Mars in 2027. Once in Mars orbit, the probes will fly in formation, mapping the Martian magnetic field's upper atmosphere and ionosphere in 3 dimensions, in the process providing the first stereo view of the red planet's unique near-space environment. Escapade's principal investigator Robert Lillis from the University of California, Berkeley, says the mission will help scientists understand how and when Mars lost its atmosphere and provide key information about conditions on the planet that will help humans survive on this alien world once they get there sometime in the next decade. Lillis says understanding how the ionosphere varies will help develop better communications and navigation systems for life on Mars. Mapping the planet's magnetic fields and the response to space weather is important because Mars is neither a global magnetic field like the Earth nor a thick atmosphere like Earth to shield its surface from damaging solar storms. So anyone living on the surface of Mars will have to protect themselves from the high-energy particle radiation which damages DNA and increases the risk of cancer. Lillis says a background radiation level from the Milky Way galaxy is always present on Mars. But last year, NASA's Curiosity rover documented an intense solar storm that delivered in one day the equivalent of 100 days of normal background radiation. So this mission will be making space weather measurements to understand the system well enough to forecast solar storms whose radiation could harm astronauts on the surface of Mars or in orbit. Escapade will also pioneer a new trajectory to the red planet. Now, currently, typical missions to Mars are launched within a tight window, just a few weeks long, roughly every 26 months. That gives spacecraft the most fuel-efficient route. It's an elliptical path that allows vehicles to leave Earth orbit and insert themselves into Mars orbit at just the right time to catch the red planet as it reaches its closest orbital position to the Earth. All Mars missions up to now have used this method, known as a Hohmann transfer, which restricts launches to this once-every-2-year alignment between the Earth and Mars. But instead, Escapade will first head to a Lagrangian point. That's where the gravitational pull of the Sun and Earth are equal, and it will remain stationed there for a year in a broad kidney bean-shaped orbit that will eventually bring it back towards the Earth early in November 2026. At its closest approach, Escapade will then fire its engines to slingshot around the Earth and head out to meet Mars during its biannual alignment with the Earth. Lillis says if humans plan to settle on Mars in the future, hundreds of both manned and unmanned missions will need to be launched to resupply the colony during every alignment. Now, since the Earth has a limited number of launch pads, and weather and technical delays are also common, Escapade's flexible trajectory could allow all these spacecraft to launch over many months, queuing up in a Lagrangian position before flying off to Mars during the planetary alignment. Escapade's 2 probes will fly in different orbits around Mars, providing a three-dimensional view of how the Martian atmosphere responds to changes in the solar wind, the constant stream of charged particles flowing out from the Sun. While Mars lacks a global magnetic field like the Earth's, it does have localized magnetic fields caused by strongly magnetized crust. These so-called crustal fields are the remnants of a long-gone global magnetic field that magnetized rocks as they cooled or were altered by water. While far weaker than the Earth's magnetic field, they are locally strong enough to push the solar wind up to 1,500 kilometers away from the Martian surface. And the goal here is to better understand how the solar wind energizes the particles and helps them escape into space. You see, the escape of water and other atmospheric gases over the past 4 billion years has led to a very thin, wispy atmosphere on Mars, with less than 1% the density of Earth's atmosphere. To understand how the solar wind drives different kinds of atmospheric escape is a key piece of the puzzle to understanding the climate evolution of Mars. Escapade's stereo perspective will allow two different vantage points simultaneously, which could help determine what exactly happened to the water that once filled the lakes and rivers on Mars up to 2 billion years ago, and whether it's still available underground to be tapped by future Martian colonists. We already know that the geological evidence shows that Mars once had lots of water. But in order to keep that water, you need a thick atmosphere, one which hasn't been eroded and degassed into space. Once the satellites arrive at Mars, they'll take about 7 months to settle into lower orbits that are synchronized. Instruments aboard the probes include 2 electrostatic analyzers. They'll measure the flux and energies of particles, both ionized atoms and electrons, that are escaping from Mars. Lilith says that'll provide details on the direction the particles are going and what energies they have.
Escapade is a twin spacecraft interplanetary mission to orbit Mars to understand Mars's unique magnetosphere. This is the first ever twin satellite mission sent to Mars. Berkeley has been involved with Mars missions since the early 1990s, with the Mars Global Surveyor mission and the MAVEN mission in 2013, and then Escapade is sort of the next logical step. The 2 spacecraft are named Blue and Gold.
We know that Mars once had a warm and wet atmosphere. It was definitely thick enough that liquid water could exist on the surface. But we know also today that Mars has a very thin atmosphere that would never be able to support liquid water. So Escapade is going to help us understand how Mars lost its atmosphere. Escapade will provide us with direct measurements of the escaping particles that are leaving the planet today to be lost to space.
Because the interaction of the solar wind with the magnetosphere and the upper atmosphere of Mars is so complex, if you only have one spacecraft, you can either be measuring the effect of the interaction of the solar wind, or you can measure the solar wind, but you can't measure both at the same time.
Escapade allows us to be in 2 places at once and to simultaneously measure the cause and the effect. Escapade has 2 instruments measuring electrons and ions that are built right here at UC Berkeley.
On Escapade, the electrostatic analyzer exploits kind of a cool feature of electrons in space. Electrons of a particular energy tend to flow along magnetic field lines, and the way they're flowing along magnetic field lines can actually tell you what that magnetic field is connected to. You can tell something about the state of the plasma, the state of the atmosphere, the state of the sun from far away by measuring something really close.
The Escapade mission will be our first mission that is truly interplanetary. Because it's going to be the first time we operate spacecraft that far away from Earth, it's going to be unique for the first time for us to know that we can't have real-time information into what's happening in the spacecraft. We are simulating and training by putting in light travel time delays into our mission simulations.
We need to understand the system well enough to send astronauts safely to Mars. A very important thing to understand is how radio signals propagate within and through Mars's atmosphere. That's important for communication and navigation signals.
And in that report from the University of California, Berkeley, we heard from Escapade Principal Investigator Robert Lillis, Escapade Science Team member Gwen Hanley, Escapade Solar and Heliospherics Associate Director Phyllis Whittlesey, and Escapade Mission Operations Director Abhishek Tripathi. This is SpaceTime. Still to come, the Pleiades proving to be far bigger than originally thought, and we end debate over the origins of interstellar comet 3I Atlas. All that and more still to come on SpaceTime. A new study has shown that the famous Pleiades open star cluster is far bigger than previously thought and is actually part of an enormous stellar complex spreading across nearly 2,000 light-years. Open star clusters are groups of stars that were all born in the same stellar nursery. The Pleiades, or Seven Sisters, have been studied by humanity since antiquity. Amazingly, different cultures on different far-flung continents all refer to the same cluster as being seven sisters or seven daughters, possibly a throwback to the Dreamtime stories that originated before humans first left Africa. The new research, reported in the Astrophysical Journal, employs a new approach to tracing stellar origins. Stars are formed in dense molecular clouds of gas and dust. As pockets of this material clumps together and gains mass, it collapses under its own gravity, eventually creating what becomes a hot stellar core, around which the star then forms. Star formation often happens in bursts, with many stars forming in close proximity and succession. These open star clusters remain gravitationally bound to each other for many millennia. Eventually, tens to hundreds of million years after their formation, the star-forming material from which they emerge is ejected from their vicinity by cosmic winds, radiation, and other astrophysical phenomena. When this occurs, individual stars migrate across to other areas of their host galaxies, and it's then extremely challenging to identify their siblings and trace the chronology of their origin story, especially after 100 million or more years have passed. This new work combines data from NASA's TESS mission, ESA's Gaia spacecraft, and the Sloan Digital All-Sky Survey to show that the Pleiades cluster actually constitutes the core of a much larger structure of related stars that are distributed over more than 1,950 light-years. The study's lead author, Andrew Boyle from the University of North Carolina, Chapel Hill, says by combining data from Gaia, TESS and Sloan, the authors were able to confidently identify new members of the Pleiades. On its own, the data from each mission was insufficient to reveal the full extent of the structure. But once integrated, linking stellar motions from Gaia, rotations from TESS and chemistry from Sloan, a far more coherent picture emerged. Boyle says it was like assembling a jigsaw puzzle, where each dataset provided a different piece for the larger puzzle. Now, the authors are calling the new discovery the Greater Pleiades Complex. It contains at least 3 previously known groups of stars, and likely 2 more. Boyle and colleagues were able to determine that most of the members of this structure originated in the same giant stellar nursery. One of the keys of their approach is the fact that the speed of a star's rotation usually slows as it ages. Their work leveraged a combination of stellar rotation observations from TESS, which were designed to identify exoplanets in transit in front of their host stars, and observations of stellar motion from Gaia, which was designed to map the Milky Way galaxy. Using this information, they developed a new rotational-based way to single out and identify stars that share a common origin story. Beyond having complex ages, the authors also demonstrated that the stars in the Greater Pleiades complex have similar chemical compositions, and that these stars all used to be much closer together. Combined, the evidence is overwhelming. This is SpaceTime. Still to come, the ongoing debate over the origins and nature of the interstellar object 3I Atlas, and later in the science report, researchers find a new way to discourage seagulls from trying to steal your food at the beach. All that and more still to come on SpaceTime. Well, I know we've spoken about this before, but the ongoing debate over the origins and nature of the interstellar object 3I Atlas is continuing to pervade some sections of the media. The thing is, the evidence continues to point in just one direction. 3I Atlas is a comet, not an alien spacecraft. Just like a comet, 3I Atlas has swooped behind the Sun and emerged on the other side. And just as predicted, the comet's on a trajectory that will bring it to within 268 million kilometres of the Earth on December the 19th, passing safely by. There has been no strange manoeuvring towards the Earth, no slowing down, and no abrupt turns. It displays classic cometary features, including a tail, a coma around its nucleus, the outgassing of volatile materials, and an evolution in its brightness as it approached the heat of the Sun. The so-called anomalies which conspiracy theorists have been pointing to are all perfectly plausible characteristics for an interstellar comet. That's because these objects would have very different compositions, would have been subjected to very different radiation histories, and would be travelling at far higher velocities towards the Sun than those seen from your typical Oort cloud or Kuiper belt comet, so none of this should come as a surprise. What makes 3I Atlas remarkable is where its outgassing begins, with hydroxyls, a surrogate for water, being detected much further out from the Sun than typical solar system comets, which at those sort of distances are still quiet. The comet's high gas plume nickel content, unusually low water fraction, rapid brightening and non-gravitational acceleration suggesting a higher than normal rate of mass loss, are all consistent with a body whose origin is in a star system with a very different elemental composition to our own solar system. And that's exactly what one would expect from an interstellar object. Those supporting the alien spacecraft hypothesis claim that 3I Atlas was on a retrograde trajectory, almost aligned with the ecliptic, the plane around the Sun on which all the planets orbit. And they say its point of origin was close to the coordinates of the famous WOW signal, an unexplained signal picked up by a radio telescope in the 1970s, which is now thought to have emanated from a pulsar. But none of this means that 3I Atlas is a spacecraft. Or more accurately, those pushing the conspiracy theories can't prove how this does mean it's a spacecraft. Other claims by conspiracy theorists appear to rely on flawed statistics and misinterpretations or uncertainties so large as to make the anomalies unconvincing. To quote the great astronomer Carl Sagan, extraordinary claims require extraordinary evidence. And so far, it's just not there. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study claims drinking coffee can protect against atrial fibrillation, a common heart rhythm disorder that causes rapid irregular heartbeats and can lead to stroke, heart failure, and ultimately death. The findings, reported in the Journal of the American Medical Association, contradict earlier recommendations that people with heart issues like AFib should avoid caffeine out of fear that it will trigger symptoms. However, the new research by the University of Adelaide followed 200 participants, concluding that drinking a cup of caffeinated coffee every day actually reduced AFib by 39%. The authors say coffee increases physical activity, which is known to reduce atrial fibrillation, and it's also a diuretic, which could potentially reduce blood pressure and, in turn, lessen AFib risk. They say several other ingredients in coffee also have anti-inflammatory properties, and that could have positive effects as well. In South Australia, the growing algal bloom problem is continuing to plague the state's coastal waters, in the process causing an ongoing mass killing of marine life. The bloom, which began back in March, has already killed millions of animals, wiping out entire ecosystems. Now, research by the University of Technology Sydney has identified the dominant species of the algae responsible for the toxins within the bloom, Carenia cristata. It's the first time the species has been detected in Australian waters. It's one of 5 Carenia species present, and the only one known to produce brief toxins, a suite of cyclic polyether compounds, which are neurotoxins that bind to voltage-gated sodium channels in nerve cells. This causes disruption of normal neurological processes, resulting in neurotoxic shellfish poisoning. The South Australian state government says the bloom was triggered by floodwaters from the River Murray in 2022 and 23, which brought extra nutrients into the sea. There was also cold water upwelling in the summer of 23-24, which lifted more nutrients to the surface. And there have been marine heat waves since September 2024, which increased water temperatures by some 2.5 degrees Celsius. Researchers have found a new way to discourage seagulls from trying to steal your food at the beach. A report in the journal Biological Letters claims simply shouting at the feathered fiends was enough to cause them to back off. The authors used recordings of men either speaking or shouting at the seagulls and found that the gulls responded to the tone of the shout far more fearfully. Among some of the great myths about plants are whether talking to them really helps them grow or whether they prefer classical music to death metal. Of course, neither claims are true, but the myths persist. Tim Mendham from Australian Skeptics says now there's a new book exposing the pseudoscience and putting the facts straight.
This book is by a fellow named Tim Entwistle, who used to be the head of the Botanical Gardens in Melbourne, and he's a friend of the Skeptics, which is how I knew him, because he wrote some articles for our magazine, The Skeptic, and basically looking at a lot of issues of botany and plant growth and all sorts of areas like that. Now, this has been an area which has been of interest to paranormal people and skeptics, therefore, for a while. I don't know if any of your listeners would remember a book called The Secret Life of Plants, which I think came out in the 70s or something like that, which had a lot of myths that then cemented themselves in the zeitgeist of the time. And basically things like you can talk to plants, you can influence plants through music and that sort of stuff, and help them grow or hinder their growth, etc., if you play the right sort of tunes. And the old story of then Prince Charles talking to his plants and that sort of stuff to encourage them. A lot of people claim that you could if you play classical music to a plant, that would make them grow better. If you played heavy metal, they shrink up and die. Plants with particular musical tastes. And a whole range of other things. And you get stories of, do trees talk to each other? Can plants warn each other about something approaching, like a swarm of locusts or something like that? How do plants react to human beings and all sorts of things? There's a lot of myths out there. Sometimes little aspects that are actually have some basis in truth, like trees under stress.
Talk to each other by releasing certain chemicals, either through their roots or through their leaves, that act as warning signs for other trees.
Yes, it's not so much warning. It's just basically a tree is under stress, and it releases the chemicals, and the others react to that. So it's hardly say, hey, next plant to me, watch out, they're coming.
I guess it depends on what your terminology for conversation is.
Yes, yeah. There are certain aspects which then get picked up. I doubt if these things were necessarily known to the authors of Secret Life of Plants. So there are some aspects, but very interesting things of what plants do. Obviously, plants react to sunlight and all sorts of stimuli and various things, touch. So there's some fascinating things about plants, which is what Tim is talking about.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.